Internet of Things defines a network composed of multiple elements of different sizes, shapes, and functions. Currently, there lacks a means to represent and manipulate large IoT data resource trees in a visually intuitive and application consumable manner. So we set out to change this. Our goals were as follows. The first one is to create a visualization tool to render a million data points in a web browser. And the second one is to support for managing server-side data via the client. The third one is to minimize latency for client rendering. And the fourth one is to view data in near real time.
This visual describes a systematic interaction between all of our components. The color yellow represents ODL. Green represents all of our server-side code. Red represents the browser, and blue represents the client-side user features. Open Daylight is a software-defined networking controller platform used for big data collection and distribution. We are running this as a server on our EC2 instance. You interact with this ODL server through CRUD operations sent through HTTP. We utilize the Python library requests to recursively walk through our tree and retrieve all of the attributes for each node. Next, we parsed all of the data we retrieved from each node into a cumulative JSON format. We used the shape of the tree and the number of nodes to calculate the position for each node in the visual to minimize overlap when rendering. Finally, we re-encode our JSON into the format required by sigma.js, our visualization library. However, walking the tree and generating the corresponding Sigma.js JSON can take quite a long time as trees get very large. This is much too long for a user to wait when loading up the visualization in the web browser. To combat this, rather than generating the JSON on demand, we pre-compile it and merely serve up the static JSON file to the client's web browser. This ensures we have super smooth and low latency render. We have a cron job on the server that generates a new JSON file every 10 minutes. This gives us near real-time visualization client-side without incurring a time penalty. Clicking on a resource, such as an AE, container, or content instance, pulls up a side panel containing all of the attributes of that node. Among these include the resource's name, ID, type, size, number of children, as well as links to its parent and child nodes. For nodes with an extremely large number of data points, called content instances, it may be difficult to find the most recent collected data point. To make this easier, we've added a button called Latest, which will conveniently grab and display this latest data. From this panel, you can also edit the tree. You can edit or delete the existing node, or even create new ones. These CRUD calls to ODL are done via AJAX and jQuery. You can easily filter or search the visualization if you know the name of a specific resource, resource type, or attribute. In order to be more real-time, we've added the option to refresh the tree. The user can choose to either refresh the whole tree, thereby incurring a potentially large time penalty, or choose to merely update the current node, along with a user-specified level depth to render. This results in a much quicker render while still giving the user the real-time data they want. We feel this flexibility is a very good trade-off between functionality and usability.
We've learned a lot of things through the whole project. Some of the group members came from non-CS background. They haven't used Python or JavaScript before and have to start from scratch. Through the whole project, we've learned how to use Python to write scripts, sending HTTP message to get the tree data based on different situations. We've learned how to use JavaScript jQuery to render a good, easy-to-use interface for users to interact with the tree just through their browser. And we've learned how to send AJAX call to server to do a normal HTTP method or call server-side Python script through the client side. We've learned agile development environment to have a 2-week sprint for the project, and we are comfortable showing progress after a sprint. And we've learned how to set up EC2 instance to run the tree online so that 3 of us can share the same tree and have the same visualization tool to use. And finally, we have learned how to enable CGI in Apache to make it accept server-side AJAX call for the Python script. And also, we are kind of right now familiar with the version control tool GitHub. The 3 of us can share the same code after at the same time. And now we will show you everything we have for this visualization tool. Okay, right now we will do the demonstration for our visualization tool. And just a quick mention that the CORS extension, as we documented in the GitHub, its name is allow control allow origin. It must be installed in the Chrome at first, and right now we can only use Chrome to operate this visualization tool correctly. So we already have a visualization tool implemented in our EC2 instance. So right now this is the tree, and there are basically 4 colors for this, and I will explain that one by one. So the in CSE one, which is the CSE base type, this is the highest root node in the whole tree. It only has one in CSE1 in each tree. And the orange one, which is the resource type AE, it's the largest repository of things. For example, one AE can have a temperature data for the temperature data under it, and the another AE contains all the humid data for it. So this is AE, and the green one is the container. So container has two functions. That one, it can be represented as a real data, as a real sensor. So here we have SD5 container, which can be represented as the sensor of the temperature, and this is the real sensor. And here we have the let's see, we have the 00C, which contains 4 container. So at this point, this container contains a group of sensors. So it can be represent all the temperature sensors in Boston, for example. So these are 2 containers function. And the blue dot is the content instance, which represents the real data for this. So the raw tree data is a JSON file, and we are using Sigma.js to render a nice view of this JSON file. And special thanks to Ada recommending a existing web app, which is this, doing this kind of network rendering things. And also special thanks to Oxford International Institute. Oxford Internet Institute. They have this open source project that we can directly use and modify. And so let's get into the function of the visualization tool. So there are 3 buttons down below, which is zoom in, zoom out, and get back to normal view. So when you click a node, it will gives you the attributes of this specific node, and also it will tells you the parent and the children list. So these are all clickable. When you click that, they will also show the attribute list here. So it will also gives you a edit button. When you click edit, there will be 3 options for you to choose. You can create things under it, or you can update the label of it, since the label is the only one that can be modified under container. and also you can delete it. So let's start with create. Let's say under SD5 we need to create a content instance called SD5CI and give it some labels. So after you hit create, it will directly go to the tree, create the thing, and gives back a new whole tree data, and it will represent you the content instance you have created. So we have SD5CI here, and also you can delete this SD5CI and just hit edit, delete, and it will refresh the whole tree again and delete the things. And also you can modify the label of this, like let's say updated, and hit update. It will also refresh the tree and update the label, so it says updated. And we also have a button that called latest, which only can be used under a container. It will gives you back the latest content instance in it. So for example, here we have thi4, which is a container, contains bunch of content instance. If we hit the latest button, it will gives you back the resource name of the content instance, that it's the latest one, latest content instance in it. So how we done this is basically every button is a AJAX call sending a CRUD. So it contains HTTP put or post or delete method to the tree, including preformed data in it. So let's return to the main panel. You can also select nodes using the group selector. So if we click this, you will see 4 colors representing 4 types of things. You can choose container, which will give you back all the containers, or you can choose all the container instance here, and pretty much that's it. So this is the group selector. And to get the latest version of the tree, we just need to click whole tree, which will trigger a AJAX call calling server-side Python code to execute again and gives the user back a new JSON file of the tree data. So how we done this is we implement an AJAX call in this button, and it will send a AJAX call calling server-side Python to generate a file and refresh the page so that the user is getting the new IoT-JSON file from the server again, so that it's getting the latest tree. Okay, here we are going to talk about our solutions for a big tree. So right now we have pretty much over 100 node gear, and so what our solution for the big tree is, you can do a bunch of things to narrow your tree down. So first, you can search it by name, and let's say I want to see things that the name is AE4. So after you click enter, it will gives you back directly choosing the AE4, but not only gives you the result of AE4, but also gives you result of these. So why these are showing is that the search bar also not only search the name of the node, but also it's searching the attribute of the node. So why it's getting back the this container is because its parent ID contains AE4, this string. So this is searching so that it can narrows it down. And also when you click a node, or you can just let's say I want to see AE4 again. So under the AE4, you can have a get child button. If you click this button, it will gives you everything under AE4. So when I hit get child, it will gives me back everything under AE4. So that helps you narrow down the tree. Like if a user sees a very big tree, there's a very high possible that he doesn't want to work everything. He doesn't want to work along with the whole tree. He just want to work with part of tree, so that the get child button is letting him do this to let him get a better view of the tree, the subtree he actually wants to work on. So let's get the whole tree back again, and this is the get child button function, and also we have a limited level button here. So if you enter the depths, say I want to only have what's 2 levels under CSE1. So if I enter 2 and hit the limited level, it will only gives you back 2 levels under in CSE1. We can also have 4 levels of in CSE1, which is 4 levels, right? And that's another way to narrow the big tree down. So like maybe the user does not want to see, because as the deeper the level goes, the more constant content instance you will have, which is the real data. So maybe the user doesn't not want to see a lot of content instance there. They just want to see what sensor I have, what AE I have. So that's the limited level thing work for the user here. So let's get the whole tree back again. So that's pretty much everything, I guess. So how do we do the limited level and the get child thing? Is that we also trigger a separate Python script on the server side, but this time we also passing the parameters to Python script. Like if I want to get child under AE4, I will pass the AE4's path to as a parameter to the Python code, so that it knows it's getting things under AE4. And it also works the same in the limited level thing. So that's pretty much it. We've already put the link on the GitHub. Feel free to try it out, and thank you.